Hi everybody, this is your 14th video. In this video you're going to learn what the intermediate value theorem is and how to use it and how it will be asked on the AP exam. So before I tell you what the theorem is, I'm going to start with two different stories here, so just listen carefully and think about what I'm saying here. In the first story, let's talk about height. Now I want you to think about when you were born and how tall you were. Let's say you were 1 foot tall when you were born. Now think about and picture yourself today and how tall you are now. So you're probably between 5 and 6 feet. You're way taller. Let's say 5.5 feet. So we measure the height when you're born and you measure the height now. So the question is, are you guaranteed that you've reached every single height in between at some point in your life? So think about that for a second. Now, my second story is, let's say you start with a bank account. You open one up, you just get a job, and you're starting with $0 in your bank account. And let's say that you keep putting money in it from your job, so the amount keeps going up, and after a year you have $1,000 from saving up. The question is, if you checked your account every single day, are you guaranteed that at some point you reach every monetary value? So let's say, would you reach $520? Are you guaranteed that every single value in between $0 and $1,000 are reached? Think about that one for a second. Now the answer for the first one is, where's my thing here? Yes. When you're born, let's say this is time and this is height. You start at 1 foot tall, say. As you grow, you don't magically wake up like 3 inches taller than the day before without reaching every single height in between. So you start at a certain height, you grow and you grow and you grow. Every single height value is reached. Whereas if this is time, and your y-axis is money now, you start at $0, and let's say for a week you don't have a paycheck, and then all of a sudden you deposit like $100, so it jumps up, and then it might go up slightly with interest, and then all of a sudden you drop another bank account or bank check in there, and then another. So here you are not guaranteed to reach every single y value. And the difference here is that this function is continuous, and this function is most definitely not continuous. It's kind of like a step function, I guess. Now these two questions are related to the intermediate value theorem. So I'm going to go ahead and, actually before I state it, let me just emphasize that you should have already watched this video. Okay, and now we're moving on to this one. So here is the intermediate value theorem. Now I am going to say it in like textbook big words here. So when you read this, you're probably going to wonder what the heck just happened. I have no idea what that means. So I'm also going to say it in small words, more easy to understand. So the IVT says that if f is continuous on a closed interval a and b, where a and b are x values, and n is any number between f of a and f of b. So n, f of a, and f of b are all heights. Then there is a number c contained in, so that little sideways fork looking thing means contained in. So we have some x value c contained in a to b, for which f of c is n. And what this statement means is that the x value c reaches that height n. Now again, you're probably thinking, wow, I have no idea what that means. So another way of saying it is, if you don't have to lift up your pencil while drawing f from x equals a to x equals b, aka it's continuous, then you've been forced to hit every height or y value. Every height or y value in between the f of a and f of b heights. Because remember, f of a and f of b are heights themselves, they're y values. All right, so let's do a picture here because visuals help a lot with math. Before I switch slides, make sure you've copied everything down and pause it if necessary. Here we have the intermediate value theorem in picture, so a third way of saying it. We have big words, little words, and pictures now. Now this is the same picture 4 times, we're just adding more and more information to it. So this is really breaking it down for you. So let's start off here. We're saying if f of x is continuous from a to b. This clearly shows how a and b are x values, and I'm not lifting my pencil while I'm drawing it. And we know the first and the last y values, f of a and f of b. So here is the y value associated with A, and here is the y value associated with B. And then we are going to pick any n value. We're going to call this y value n. We're going to pick an n between f of A and f of B. So you could basically just run your finger up and down, back and forth, and at some point you're just going to stop and call that y value n. Now it has to be between f of A and f of B. It couldn't be like up here or something like that. That wouldn't work. So you're picking this n value, and then the intermediate value theorem says that there must be at least one c value between A and B so that you reach this height. So you pick your y value, and you go over to your curve, and you know that there's at least one x value that gives you that height. So then I would say f of c equals n for this point, right there. So take a second and write that down. Pause the video. Make sure your diagrams are neat and accurate, otherwise it's not going to mean anything to you. Now you might be wondering, okay, that's really, really obvious. Like the intermediate value theorem is one of the easiest, most obvious theorems. It's basically saying that if you draw a continuous function, every y value is reached. It almost seems too obvious, and it is very obvious. We're going to have other theorems later that are much more complicated to understand. So you might be wondering, like, who cares? Why do we even have a theorem for something so obvious? And one of the reasons is because of the intermediate value theorem, computers and calculators can find a zero or an x-intercept or an intersection point between two curves. The method that your calculator uses asks for a lower and upper bound, and it narrows in on the guaranteed answer or the guaranteed c value, only if it's continuous. So jot that down and let me show you on the calculator here. Let's say you graph, come on. There we go. You're going to graph this parabola here on the standard viewing window. And you've done this many times before, but you've probably never realized what is actually happening here. Or maybe you've thought about it, but you didn't realize it was actually calculus. So if I find a zero or an x-intercept, the calculator's asking me for a left bound. And then the calculator is asking me for a right bound. And then what happens is once you give it a right bound, it's using the intermediate value theorem properties to narrow in on the actual x-intercept. And if I did another function, I could find the intersection point. But that's why it asks for a left and right bound. It uses the IVT to narrow in on the actual solution. So let's talk about how this would be worded on an AP exam and what kinds of math skills you would need. So right here, I want you to identify A, B, f of A, f of B, n, and c for this IVT problem. Now realize that A and B are x values, f of A, f of B, and n are all y values, and c is an x value. It's easy to get that mixed up here. So I have this function here, x squared plus x minus 1, and I want to find c, that x value, in between 0 and 5, so that f of c is 11. So that at that mystery x value, my height is 11. Now, before you ever do a problem like this, you need to verify it's continuous. Otherwise, you're doing all this work for nothing. Because if it's not continuous, you can't guarantee that every y value is hit. Because it could jump over a bunch of y values and miss them. Now, this is a parabola. It's a polynomial. Polynomials are always continuous. So let's identify A and B. That's the easiest. A and B are the x values, the end points of what I'm considering. So those are definitely 0 and 5. Now f of A, that's not too bad either. All I have to do is evaluate my function at 0. So I have 0 squared plus 0 minus 1. So I have negative 1. And then f of B becomes f of 5. So now I have 5 squared plus 5 minus 1. 25 plus 5 is 30. 30 minus 1 is 29. All right, that wasn't too bad. Now I have to find n. Now remember, n is the y value that you want to reach. Well, it's telling me right here that I want to reach 11 for that mystery x value. So I'm going to call n 11 here. Because again, that's the height or the y value I want. And now I need that c such that when I plug c in the function, I get 11. And that's the key. When I plug c in, I get a y value of 11. So what I'm going to do here is take my function with x's still, because x is the mystery. I want to know what x is. When I'm done, I'll call it c. And I want my y value to be 11. So we know how to solve these. I'm going to subtract 11 and I get minus 12. Do not add 1 and just have a constant here and try to do some funky math. You have to factor. That's the only way to solve this thing. So I'm going to do negative 3 and 4 because they multiply to negative 12 and add to 1. And then I get x equals 3 and x equals negative 4. Do not just stop here and mindlessly leave this as your answer. You have to kind of visualize what's going on here. A was 0, B was 5, f of A, negative 1, so I'm actually starting down here. F of B is 29. And then my curve is somehow in between here. I was looking for the x value between 0 and 5 so that I had a height of 11. So if you actually go over, this is very inaccurate, but this is giving you the general idea. If my picture were accurate, this is where your C value would be. Now look at these x values here, and one of them can immediately be discarded because I'm only on the interval 0 to 5. So obviously this guy is gone. I'm looking at 3. So the mystery solved here. If I were to plug 3 into my function to have a height of 11, so that means C is 3. And that means I can also say now that f, oh my god. There we go. That f of 3 is 11. Instead of just saying f of c is 11. So what I want you to do is, you finished your 2 video notes, and then at the beginning of these video notes, right up here, you have that little slip of paper with the visuals on it for the IVT that I had you tape down. Then you have these notes. Now I want you to go ahead and do those 2 problems on the half sheet that I gave you. It had those fill in the blanks. Those aren't too bad, but I do want you to have, in addition to filling out the blanks, I want you to have a well-labeled diagram, kind of like this, or like this right here. And we'll practice this more in class.